Hey everyone, in this video we'll be looking at the compound interest formula used with different time periods. So last time we did explore using the compound interest formula for questions that had something to do with some percent per annum, okay, and for some number of years, okay. Now if I have a look at all these questions here, okay, the first one is just the straightforward one, okay, because this is in years and that's in years. But as we go on to the next questions, all of these are compounded at different time periods. And this is a little different when we use compound interest, right? So let me explain. So the formula that we use is always A equals P bracket 1 plus R to the power of N. There is also another formula that we did explore before to do with future value as well. And then the compound interest is this formula here, which I will address when we do the first question. So let's have a look at the first question. Calculate the compound interest when $24,500 is invested at 6.3% per annum for 5 years, compounded annually. So we firstly use A equals to P bracket 1 plus R to the power of N. And our principal in this case is this value here, okay, whereas this is our percentage. So we're going to write 24,500, whoops, 24,500 times 1 plus the rate. Now, the rate you can rewrite as 0.063 once you divide this by 100. So I'm going to write that instead. And then raise that to the power of 5 years, which is right here. Okay? So once I've got that, 24,500 times 1.063 all to the power of 5, I do get this value here. $33,253.12, but there's more numbers after that, so I'm just going to write a couple of those. Okay, oops. So that's 12,057, so on. Okay, so that's our total value at the end of 5 years. But what the question is asking for is, what is the compound interest? So our compound interest formula, once we get the total amount, is compound interest equals total amount, which is A, subtracted by our principal. So it has grown to this amount. Well, we started off with this. So the difference between these two values is our interest. So we write R equals A minus P. Write our A value as that. So that's 33,253.12. And I'm just going to write dot, 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 because there's more numbers after that. Then minus P, which is 24,500. So I've got this sitting in my calculator right now. So all I've got to do is type minus 24,500, and that will get me my interest, which is $8,753 and 12 point something cents. So there's more numbers after that. And now, because this is an important number, we round this up to, or round this down, sorry, to $8,753.12. Okay. So once we've done that, now we can explore another question where we're compounding twice a year instead of once a year. So we're going to use the same formula. Okay, A equals P bracket 1 plus R to the power of N. Our principal was this value here. It's exact same as before. I've just copied it there. And the rate in this case, well, this is per annum. So I'm going to write 0.063 first. But because we're compounding twice a year, what that means is that the bank would choose to multiply this value by some decimal here, and it will raise the value by some percentage twice a year. So in the first half of the year, it would raise this amount, and it would turn into some value that's bigger than this. And then after that, it's going to do it again. Okay? So how this works is that this is going to divide by 2 because you want a half yearly rate. So you're going to divide this by 2. Okay? That will be to the power of now n. Now n here has to follow the exact same duration as this. So this is half yearly. Okay? How many half years are there in 5 years? Okay, so we've got 5 years in total. I'm just going to write that here. N equals 5 years. So how many halves of a year fit into 5 years? That will be 10. And it's the same thing as getting 5 here times by 2. Okay. So this is 24,500 times 1 plus 0.063 over 2 to the power of 10. And this will get us 33,408.610 and so forth. Okay, so if you wanted to know in detail what happens actually in this part of the process, well, 0.063 divided by 2 is going to be this, 1.0315. Okay, so all I've done was get that as an answer on my calculator and add it with 1, and I got this. And this is raised to the power of 10. Okay, so if I was doing it for, just 1 year, it would just be 2. Okay, and if it is for just 1/2 of a year, it'd be power 1. So if you put it to power of 10, that means you're multiplying this by 1.0315 10 times, okay? Meaning that the principal here would change all the time. So after 6 months, it would change to this value, okay? And whatever this value is, it's multiplied by this rate again, this ratio again, and it's going to raise this particular value by basically 3.15%. And then this whole value, whatever that returns to us, is going to now be multiplied by the same rate again. Okay, so you can see that our principal keeps on changing every single time. And it's changing more often than just 1 year. It's changing every half a year. Okay, which is good. So now we've got this here. All right, let me just put that on my calculator again, just so I don't lose it. Okay, I've got it on my calculator. Then we've got our interest equal to 33408.610. That's the number that we just got. Then we subtract it by 24,500. So if I do that, I will get 8,908.610, so on. And so that rounds to around 8,908.61. Okay? Right, so that's our interest. Now, if you have a look at a comparison of our first interest, yeah, 8,700 something, this is now 8,900 something. Okay, so it's lifted up by a little bit. Let's look at what happens if you compound this quarterly, which means every quarter of a year or 3 months, the bank will give you extra interest based on what your current principal is. We're going to use our formula again. A is equal to P bracket 1 plus R to power n. Our P value was 24,500. Now we're going to multiply that by 1 plus the rate. Just before I do that, I'm just going to put this here. So our rate is this, but this is per annum. So if we want this to be a quarterly rate, we're going to divide this rate here by number 4. So we're going to write 0.063, but divided by 4. And usually it's 5 years. So we're just going to put that to the power of 5. That's in years. But in 5 years' time, each year has 4 quarters. So we're just going to multiply that by 4. And you know that's going to be 20. So putting this on our calculators will give us, let's check. Okay, so it gives me 33,489.040, so forth. Now, that would be basically higher than this previous value. Okay, just letting you know that. But our interest is now this value that we just got. So I'm just going to copy that down. That's our amount at the end of 5 years, minus our principal, which is 24,500. And I've got that number sitting in my calculator, so I'm just going to subtract 24,500, and I will get $8,989 and 4 point something cents. So it keeps on going. But because we only need to round to 2 decimal places, I will get 8,989 and 4 cents. Okay. All right. Now let's compound monthly instead. Okay. So you can see that these compounding durations. Okay, this was twice a year. This is now 4 times a year, how many times is this happening per year? If it's monthly, then it's 12 times a year. Okay, so we're increasing the number of times we're compounding. Okay, let's see what happens. A equals to P bracket 1 plus R to power of n. So our principal in this case is 24,500, then 1 plus 6.3%, which is 0.063. But we've got to divide this number here by 12 to get a monthly rate. So we divide that by 12. We raise it to the power of 5 years, but 5 years worth of 12 months is the same thing as 5 times 12, which is 60 months. And we type that directly on our calculators. So that gives us a total of 33,543.701 something. Our interest is given by our final amount, which is A minus our principal. So I'll just copy down that amount that I just got. And then I'm going to subtract that by our principal, which is 24,500. Okay. This gives us our first value that's over 9,000. So 9043.701 and so forth. And if I round that to two decimal places, well, I get this value here. Okay. So if you have a look at these amounts here, which I'll highlight in a different color, focus on them. We've got 8,753. We've got 8,900 and something, 8,900 something, and then now I've got 9,000. So you can see that it's increasing over time as the number of times I compound per year increases. Okay, so let's have a look on the next page where we dive into another question where we compound even more frequently. All right. So last time we're looking at months. This time we're looking at fortnights. Let's start with the formula. A is equal to P bracket 1 plus R to the power of n. Our principal being 24,500 times by 1 plus the rate, which is 0.063. But the number of fortnights we have in a year is 26. The number of years we are investing this amount is 5 years. We multiply this by 26 to find out how many fortnights are there in 5 years. We put this in our calculators. Okay, so that will give me 33,558.564 and so forth. Our interest again is this amount subtracted by our principal. So if I then just subtract 24,500 in my calculator, I get 0.564 and so forth. And that would round down to 9058.56. Okay, so we get this amount of interest if we invest this much amount of money compounded fortnightly. Okay. Now for question F, it says compounded every 6 months. Now, this question, believe it or not, we actually already did. So I'm just going to copy paste what I did before. This is just written just slightly differently. So if I look back at my previous solution here, where it goes compounded twice a year, this is the same thing as every 6 months. Okay, every 6 months, if you think about it, means that there's twice in a year that this happens. So I'm just going to copy this one over. Okay. All right, so again, compounding every 6 months means half yearly. But what about this one? If we compounded weekly, what's going to happen? You'll have A is equal to P bracket 1 plus R to the power of n. You'll get your principal as 24,500 and 5 years. Okay. So what's 1 plus the rate, which in this case is 6.3%, we're going to write 0.063. But how many weeks are there in a year? There are a total of 52 weeks. And we raise it to the power of n, which we know as 5 years. But each year is 52 weeks, so we multiply by 52. So you know what? After doing so many questions, you notice that you divide by 52 here and times by 52 here. Okay, that's a general trend. So typing that into our calculators would get us, I got 33,564.952, and there's more numbers after that. Our interest is going to be 33,564.952, more numbers, subtracted by our principal in this case, which is 24,500. Now that will get us 90,000, oh, it's not 90,000, 9,064.952 for, oh, not 9529 actually, so on. And this rounds to 9064.95, two decimal places. Okay, so if we look at now this amount here and the fortnightly amount, okay, so the fortnightly amount, if you compare those two values, that and that, you can see that the weekly one is higher slightly. Okay, now what's another duration that is even less than weekly? Let's say we compound daily instead. So if we compound daily, what this means is every single day the bank would give you interest based on your current principal. Okay, so we have our principal as 24,500. We're going to do 1 plus 0.063 as usual, but we divide by 365 since there are that many days in a year. We're going to raise it to power 5 years, but multiply that 5 with 365 also. Now that will give us, just double check that. Okay, that's a lot to type in. So this answer will give us 33,570.440, so forth. Our interest is now going to be A minus B, as you know. That will be 33,570.440, and so forth, minus our principal at the beginning, which is 24,500. So that would be, in our calculators, it would be 90,000, oh no, 9,070, made the same mistake as before, 0.440 and so forth, and that rounds to this number here, two decimal places. Okay, right. Part A, which compounding period should be chosen to earn the most interest and why? So if we have a look at all our answers now from the very start, okay, this doesn't give much interest. That's just 8,700 something. And it goes more and more and more as soon as the compounding periods are more frequent in a year. So the most frequent that we have, okay, is fortnights, then weekly, and then daily. We can see that as we get to from this amount, 9,058 to 9,064 to 9,070. This gives us this much interest within 5 years. Okay? So that's because our principal keeps changing because every single day the principal is raised by this percentage, whatever that is. Okay? I'll calculate that actually. So if I just put that bit on my calculator, let me just double check that, 0.063, 365 times 100. Okay, I get this much percent every day. Okay, so if you imagine your principal being lifted up by this in a day, let me check what that is. Okay, if I do 24,500 times that, okay, I get this. If in a days, I get this amount now, and then this becomes my new principal, which I then multiply again by this value and add it on to itself. Okay, if I do that again, it's going to turn into this, 25,353.05 and so forth. So we can see that the principal keeps changing again, 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 but this is every day. So you can imagine how much interest you'd be gaining if your principal keeps changing. Okay, so that's the power of compound interest. So for part I, the answer for this one is compounding daily. Okay, daily, since the principal earns interest every day, which is more frequent than other time periods, right? So other time periods are slower, okay, because they're every year, every 6 months, and so if it's every day, this means that we are earning, or basically, if our principal keeps changing, in this case, from that to that, this has actually interest included within that. And if we times that by some specific value, which is the 1.00017, okay, this is added onto that, then we're earning interest on interest. Okay, so this means that we're earning interest on interest more often. Okay.